1 in Algebra 2. Today, you can see from the calendar, we're going to take a look at patterns and expressions, and this stuff all over here in the standard section is prior knowledge. So this is stuff you know how to do. You may not remember, so we're going to go through some stuff. Shouldn't take too long, and then we'll have plenty of time to practice in class, okay? So let's take a look at Chapter 1, Section 1. So patterns and expressions, this kind of stuff, there's an example here of, you're playing a video game, you reach a locked gate, and here's the lock, and you can see really easily from the pattern that the 3 yellow and then the 1, now they're up here, the 3 and then the 1. So each time the pattern is turning clockwise. And so, they ask you to figure out what will be the 8th image in the pattern. So you go through and you turn it each time and you solve that. This kind of pattern problem solving is something that we see and do plenty of. We just don't always realize it. Some quick vocab: constant, variable quantity, variable, numerical expression, and algebraic expression. These are all words that you know and you've heard before, so it should be pretty quick and easy. Painless even. Alright, so identifying a pattern. Look at the figures from left to right. What is the pattern? What would the next figure in the pattern look like? So sometimes they're shapes, sometimes they're blocks, numbers, lines, dots, all sorts of different ways to have patterns appear. This has 3 sides, this is 4, this has 5, this has 6. So the next pattern is going to be a 7-sided shape, a heptagon or a septagon, for example. Different way to say it. So let's take a look at the got it right here. Look at the figures from left to the right. What is the pattern, and can you draw the next figure in the pattern? So each time we can see this really easily, and I'm not going to draw it because my drawing is terrible. But you can see right here we have a block in the middle that's red, and then each time we have 1 on the outside. Then we have a block in the middle that's red, and then 2 each time, or on each side. Then a block in the middle that's red, and then 3. So obviously the next one is going to be a block in the middle that is red, and then 4 blocks extending from each side of the square. Easy peasy, okay? This stuff probably seems very elementary, and that's a good thing. A mathematical quantity is anything that can be measured or counted. The value of a quantity and its measure is its measure, or the number of items that are counted. So quantities whose values do not change are called constants. So if something never changes, that's a constant. In other situations, the value of a quantity can change, and those are called variable quantities. So terms like variable, I mean, you guys know, n, x, these are variables. A numeric expression is just, expression means that there's a symbol, an operational symbol in there. So if it's numerical, it's just all numbers. And an algebraic expression is when we introduced the alphabet into the math and made things very inconvenient for many of you, okay? So these are just terms you need to understand. You're never really going to be asked to define these, but you're going to be asked to use them or understand them. We use tables a lot of the times. Tables are a convenient way to organize data and discover patterns. They work as input-output machines. This is all review from I mean, even before Algebra 1. This is pre-algebra stuff. Input-output within a table is something that we see a lot of. So we can express a pattern using algebra. So how many toothpicks are in the 20th figure? Well, we don't want to draw all 20 figures. So what are we able to do? Well, you make a table. In figure 1, there were 4 toothpicks. So this is 1, and then the process column is basically what's going on. What do we have to do to the input to get to the output? Well, if this is 1 and that's 4, and this is 2 and that's 8, and this is 3 and that's 12, we figure out that we're just multiplying the number each time by 4. So then basically what we can say is that no matter, however many, whatever turn it is, we're going to multiply that by 4, and that's the number of toothpicks. So rather than draw every figure, what we can figure out is that in the 20th, we would multiply that by 4, and so there would be 80 toothpicks. Pretty easy, okay? What is an expression that describes the number of toothpicks in the nth figure? Well, in the nth figure, we would just say that it's 4n. That's no matter what number it is, whatever figure, the 1,000th figure number, that's fine. It's just that number times 4. So the got it here says how many tiles are in the 25th figure in this pattern, okay? So the 25th figure in this pattern. So what we want to do, the screen just got much, much smaller for you guys. Okay, sorry about that. What we want to do is we want to say how many tiles are in the 25th figure. So in the first figure, how many tiles are there? Well, in the first figure, there are 4, right? In the second figure, there are 6. In the third figure, there are now 8. So what you have to do is you have to figure out what's happening. Okay, what's happening each time? Is it doubling? Well, no. Is it multiplying by 4? Well, no. That doesn't work. So you have to kind of figure out What if I double 1 and add 2 to it? Okay, so double 1, that's 2, and then 2 plus 2 is 4. So if I double it and then add 2, so 2n plus 2. That works every time. 2 times 2 plus 2, 2 times 3 plus 2. That works each time. So if we want to know the 25th, then we would just do, so on the 25th, we would do 2 times 25 plus 2. And that gives us 52. Easy enough. Figuring out this pattern, that's the hard part, okay? But you can do that with the table. And you guys have done stuff like that before. Problem 3, using a graph. You want to set up an aquarium, you need to determine what size tank to buy. The graph shows all this and that. If you want 5 2-inch platies, 4 1-inch guppies, and a 3-inch loach, which is a weird name for a fish, which is the smallest capacity tank you can buy, 15 gallon, 20 gallon, or 25 gallon, and then use a table to answer. So let's see what this looks like on the next page. We end up with, we're going to choose some points on the graph, okay, and then we end up, you know, the input 0. If you go back, let me go back here for you. You know, if we obviously we have 0, then we get, you know, a 2-gallon tank. Obviously, we're not going to buy a tank if we are buying 0 fish. That would be ridiculous. So then you take the combined length of the fish. So we add up, you know, all these, the combined length of them, 5 2-inch platies, you know, 10, 14, and then a 3-inch loach, that's 17. So that gives us all the way out to here, and then it tells us, you know, we got to go up here and figure out what size tank to buy. So to do all that, we're going to make this table right here. All right, let's do this let me make this a little bit easier and put this on the same page for you. Okay, so there, now we have it all on the same page. We can see we have input 0, and then the process column is 2, so that's fine. What about 5? So we go out here to 5, and that's up here at 7. So from 5 to 7. We go over here to 10, and 10 is all the way up here at 12. So we see each time that all we're doing is we're taking the input and adding 2. So what I know, because of that, is that if I want a total of, you know, 18 gallons or whatever it is, then I'm going to buy a tank that fits that. My choices on tanks were 15, 20, or 25. So even though 17 plus 2 is 19, there's no 19-gallon tanks at the store because the store owner doesn't like the number 19, so they don't carry those. So we buy the 20-gallon tank. Okay, let's take a look here. The graph at the right shows the cost of platies at the aquarium shop. Use a table to answer the question. So how much does 6 platies cost? Well, it's on its way up here. So, you know, a lot of you are just seeing this as a line, and you can do that. That's fine. 0 obviously costs 0. 1 costs 2. 2 costs 4. And you can see really quick that it's just doubling. Okay, it's just doubling each time. 3 costs 6. So, well, this is easy. How much do 6 cost? Well, 6 are going to cost 12. How much do 10 cost? Well, 10 are going to cost 20. Why is the graph in problem 3 a line? Well, the graph at the right is a set of points. Well, let's kind of understand what's happening here. The graph in problem 3, it says, all right, why is the graph in problem 3 a line while the graph at the right is a set of points? It's a good question. Why is that? Take a second, think about that, see if you can come up with an answer. Pause the video here and come up with an answer to 3C. So, what did you put? So why is the graph in problem 3 a line while the graph at the right is a set of points? Well, you have to understand that the number of platies, the number of fish, has to be a whole number, whereas the length of the fish can be a fraction or a decimal. So we have to take these problems sometimes and apply real-world ideas and constructs to them, okay? That's it for 1-1. It was not very hard. What I would like for you guys to do is the video is going to end here. Go ahead and pause the screen or whatever you want to do. Just take a screenshot of it or something. I'd like for you to do these 7 problems. Do this lesson check when you get to class next time. We'll take a look at how you did. If the answers are in the back, so we'll check these when you get to class on your own next time and see how we did with patterns. All right? That was easy. It was quick, painless. See you next time. Bye.